Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 2 and we're on question number 30. This is our last question of this chapter. And in this question we're asked to evaluate this line integral around the curve C, which you can see here on the left side. And if you try to just parameterize the curve and then substitute in for, convert the whole line integral into the parameter t, it's going to be pretty hard to evaluate. The trick here is to use Green's theorem. I'll just remind you what Green's theorem says. Green's theorem says that if you have a simple closed positively oriented, in other words, it's going counterclockwise, positively oriented curve, then the line integral around that curve, we can write it like that, which is of the form m dx, m is some function of x and y, plus n dy, is actually equal to the double integral around the region R, which is inside of that, curve, of the partial derivative of n with respect to x minus the partial derivative of m with respect to y, and this is over the region. And this is really handy. You can see that if nx equals my, in other words, if we were talking about a gradient field, then this just ends up being 0, which is what we would expect for a gradient field, because we have because the beginning and the end of the curve is the same point, so that makes sense. But if in this case we're not talking about a gradient field, so we actually have to figure out what nx and my are. Well, nx, remember this is our n here, and this is our m. So the partial derivative of n with respect to x is going to be 2, and the partial derivative of m with respect to y is going to be -1. So this integral is going to be 2 minus -1, which is 3. Now we just have to figure out what the limits of integration are, dy dx. Dx we can take from 0 to 2, and then this line right here is the line y equals x, because it starts at 0, 0 and ends at 2, 2. So y is equal to, y goes from 0 to x. So now we just integrate this, and it's much easier than trying to calculate this line integral directly. So we get, let's see, we can factor the 3 out, and this goes from 0 to 2, and then we have y, a value, the integral of 1 is y, so now we evaluate it at x, and we get x minus 0 dx. So this is going to be x squared over 2, so we get 3 halves out front, and then x squared evaluated from 0 to 2, which is going to give us 3 halves times 4, which is 6. So our answer is C.